mathematical abilities in everyday life, then you just can't do this, okay? So, it will be conceptual and also quantitative, okay? Some quantitative things have to be there. Okay? So, let me just have some water. And so, today is our last class. And we are open to many questions and comments, but I have only one question that had been actually written. It is that if I could talk as much as you can about your experience with the COVID-19 observatory. Well, okay, so as much as I can would take the day. But, okay, as much as I can, given limited time. So, in March 2020, when you had this starting of the COVID-19 epidemic in Brazil, together with, initially with two colleagues, we started to do some calculations about the epidemic curve. These calculations were initially very, very simple, just calculating the time it takes to double the number of cases. So doubling time of number of cases, because this is an exponential at the beginning, the doubling time is constant. So, and curiously, because, well, first, at the first week of March, we had a workshop about modeling epidemics here at the Institute, at the ICTP, a 3-day or 4 days workshop, which has nothing to do in principle with COVID, okay? But it was half an year before it was announced, okay? But well, it came conveniently, and it happened that one of the, it was a small workshop. We had only 3 persons being invited from abroad, and some people from São Paulo and some people from Rio, and that's it. It was limited, I think. Okay? But by chance, one of the persons which was invited, this is Sarah del Valle, is a specialist in influenza modeling, which is also respiratory and so on, and obviously she would go to COVID. And her experience was something very nice, actually, that in the beginning of March, she already came with a mask. And saying, well, my experience with influenza is that all the models fit better when you consider people that should have masks. So I think masks would be important. At the time, nobody actually paid attention to the mask. Everybody was washing their hands. Okay? Well, this changed it later, but okay. So, and also one person from Rio de Janeiro, from the institute called Fiocruz, which is Fundação Oswaldo Cruz, from the epidemic modeling group was there, also modeling influenza, and being also interested in what could happen to COVID. So this was interesting, and so at the last day we had a roundtable COVID-19, but suddenly, while ICTP has the people that communicate with the press and so on, there were lots of journalists there, right? So they wanted information, which made me appear in national TV at Fantastic, which next Sunday, just explaining what's an exponential curve. That was very difficult for people. What is exponential? Okay? So this made more people come and say, okay, what are you doing, and so on. So then we started, actually, let's do something with a colleague who is a former student of mine, Renato Coutinho from Federal University of ABC in the metropolitan region of São Paulo, and and Renato and Paulo Prado from the Ecology Department of University of São Paulo. So we started with the simple things, and then let's put it on a site. Okay? So we need a name. Okay, observatory. So observatory COVID-19 BR. Okay? The BR is important, but it turned out that there is another observatory which does not have the BR, which is the observatory from the Fiocruz in Rio. But we didn't know. But at the end, it was good to have the Brazil there. Yeah? So, and we put it on a site, and so we asked ourselves the typical questions that you would ask, which is, okay, what's the basic reproductive number, R0, and how fast is the epidemic developing? And so we went for data. So this was really something very important, that we had these relations to people from Fiocruz, because much of the modeling of COVID is based on modeling practices from influenza or respiratory diseases in general. So what do you need? What kind of things you need? You need the number of new cases every day, okay? Which is not available, okay? So every day there's there's a site from the government, from São Paulo, from federal, anyway, saying today we have reported X cases, 100 cases, 200 today. So this is very important not to use this. Why? So first, the notification system, okay, the reporting system, is heterogeneous through different cities and different states. So there's a lot of things that are not reported, but also reporting takes time, and it takes a reasonable time. So if you go for the true notification dates, you will see the epidemic curve doing something like this. Okay, so it's increasing and then it's falling. It's always falling. Why? Because there are cases, if this is time, there are cases here that actually exist, but has not been reported. And if you do fitting with this, you're completely wrong. Okay? Because they are reporting problem. So reporting is and this is important in which situations in terms of modeling. It is important when you are modeling outbreaks in real time or almost real time. If you are doing more, for instance, we didn't have experience with the outbreak model, the group, but we had done things in malaria, dengue, cholera. And but what we had done was using the data from the last, say, 20 years of dengue, right? But I mean, not the cases today, 2022. We can have cases from until 2021, and then depends on the question you're asking. For instance, influence of climate and of conditions to have dengue epidemics and so on, that had whole dynamics. But I mean, this has already in the past, and there's no problem with the notification delays. Things have been reported, maybe a little bit late, but okay. So now, when you do outbreak, what you need is data that. So what kind of data is available? Okay? Brazil, at this point, turned out to be okay. I mean, we don't have, in general, in Brazil, we don't have almost no testing. Okay? So people are not tested, and many of them are not notified. Okay, now, what is notified is if you get to the hospital, and if You have to stay in the hospital. This is notified and it's mandatory. Okay? So there is a database which is updated. It is updated daily, but it's available weekly. And this database is of the severe cases. And it's the same database that has been used for influenza. It's called severe acute respiratory infections, which was used for influenza, because with influenza you can develop a severe acute respiratory infection. In English it's called SARI. In Portuguese it's RAG, which is okay. Síndrome respiratória aguda grave. Okay, so this is the SARI, and in English, and this is we use for influenza. But well, the reporting of COVID-19 get to the same thing. So you could be, oh, maybe you are mixing up with the influenza. But if you go and look at the even today, the number of cases of influenza is much smaller than COVID-19. Much more. So it's actually mainly COVID. So the system notifies every suspected case. No, sorry. It notifies suspected case, but at a certain point it will be confirmed or not. Okay? And sometimes you have to test for COVID, and sometimes you just say SARI. So some difference. But with this database, this is something interesting. You can use this database, and you can say, okay, my hospitalizations are a good proxy of what actually is happening. So we can calculate quantities based on the hospitalizations. Okay? So that's what we and many other places in the world do. So, but then you have this problem here. So, the date something is reported and it's notified, I mean, and it's made public, is not a date that is epidemiologically relevant, because it depends on the administrative system of reporting. Right? So that's a problem. So usually you would like to report the date the person was infected. Right? That's important, but this you don't know. You don't know when you get it. Now, only with sexually transmitted diseases you could have this kind of thing, more or less. But for respiratory, you don't know, because you have incubation and so on, and you don't know. Maybe I have COVID and I don't know. Okay? So what this is used is the date of onset of symptoms. Okay? This is the relevant date. Okay? So when you have the symptoms. Okay? And then there's a delay between the date of the symptoms and the fact that it gets notified. Okay? And then you have the second date. That's on the database. The database is actually, it's a database where every line is one case. So it has millions of lines. Okay? It's very long, but it's very specific. It only doesn't have the public one, the name and the identification, okay? Address. This you don't know. But you have the cities, you have the state, you have the symptoms, you have if the person survived or died, how long was hospitalized, and so on, many things. So now you have the problem, however, is that the delay can be very long, like 2 or 3 weeks. When you have an outbreak, you don't want this. Okay? So what you do is to use a system. Use a statistical procedure, which is called nowcasting. So nowcasting is, as I say, a procedure that there are many ways of doing nowcasting, and which estimates from the past data the amount of cases that you have here. So you can get, in principle, you can estimate with error bars, everything, with the confidence intervals, how many cases do you have. It's sure, if you do the estimation by learning from the past. So at the very beginning of the epidemic, it was very, very rough estimation, and now we have better. And then and with some confidence. So this is was nice. So we did this. Let me show you. So and it happened in a very curious thing. So let's hope this will work. So if you want just to have an idea, where is everything? So this had just appeared. Look at the dates. So this is a very important paper about the state of art of nowcasting. Okay? So it is April 6, 2020. Had been submitted in the middle of 2019, which just came in hand. Very nice. And well, I do not know statistics well. I do almost nothing. I do average and variance and so on. But my colleague Paulo Inácio Prado from the ecology department, and ecologists know a lot of statistics, was able to implement this for Brazil quickly. Okay? And so this came in hand really at a nice moment. That's the state of art for nowcasting. And well, there's some other developments that we have actually done, but we have not published this. I mean, because we were busy with other things. It's actually a work where the leading person is Flavia. And so then okay, we can nowcast. And then we can calculate R0. How do I calculate R0? Then you have a problem. Because there are many ways of calculating R0. But one is fitting a model. Okay? But the model has many things that you don't know. And there's a work which is fantastic, which is that you do not need a model if you want to fit R0 from at the beginning of an epidemic. Because, well, at the beginning, it's exponential, okay? So what can you measure? If you have a thing that is growing exponentially, you can fit something e to RT here, okay? With some constants, and you can measure R, what's the best fit for R. So the rate, the number of cases increases. So R is available, okay? So, but we want R0. Okay? So why do you want R0? Well, because R0 is connected to many things that I showed you with the SIR model-like things. It's our model, I will show you, had many compartments. We haven't modeled them. But at the beginning, you don't need a model here. Let me explain why. So here, the R0 gives you the final size, gives you the estimated number time until a peak, and so on. So it has much more epidemiological information than this guy. Okay? But now, for SIR model, you get this E to RT, what R, remember, was something like, if I don't, there was this mu, and then there was R0 minus 1. Okay, so this where mu was, came from this equation here. Okay, this mu, which is the typical duration of the disease. But now, so You don't get R, you need to calculate R0, you also need these things. But more than this, you can do a calculation without assuming the SIR model, knowing R and knowing something which is called generation time. Generation time is the time that elapses between I get infected and I infect somebody. Okay? So it's a distribution. Okay? Everybody has a different time. So it's a distribution of generation time. Now, this thing is not known because you don't know the moment of infection. But you know the moment of symptoms. And the proxy of generation time is the serial time. The serial time is I get infected, I have the symptoms today, and the person that I infected has symptoms some other day, and this is the serial time, which is used in the place of generation time because we don't know generation time. So, knowing the serial distribution and this, we can calculate R0. I have the demonstration, it's more mathematical, okay? But this comes from the reasoning. We are growing exponentially. But every case today comes from a case some time ago, okay? So then this looking, you can write that the number of new cases today, for instance, is equal to the number of new cases, say, some days ago, times the number of new cases one person infects, okay? Which is also a distribution. Okay? So with this, you can then calculate R0 without fitting the model. Okay? But so what we did, that's the main product that exists until today, which is we think it's important for public health communication, is we have a nowcasting procedure on the number of cases, and on top of that we calculate R0 with the procedure called Wallinger-Lipsich, which is this paper here. Well, so I'm not, okay, that's here. This is based on this paper here. This is the theory. So it is already from 2007, which is how generation intervals shape the relationship between growth rate and reproductive number. Okay, it's exactly what I said. If you are interested, you can look for this. I don't want to do the calculation here. It will take us some time, and it's conceptually a little bit more mathematical than maybe we would. So this is it's the main product. But what we did also other analysis and so on. But so we put this on a site, and it is updated every week, right? Because the database is updated every week, and the site is this one. It is in Portuguese because it's main. I mean, it's for Brazilian policies. Okay. So this is the site. It's the Observatory COVID-19 and then there are many things that you have some media things here, but the main thing is you have here, for instance, states, and you go, for instance, state of São Paulo. You get a plot of COVID or just, I mean, this is COVID, confirmed COVID, and this is SARI only. Okay, so you see that's the epidemic curve, goes up there. The ones in blue are the consolidated data, and the red ones are the nowcasted data. Yeah? And then you can also go and from this calculate the effective reproductive number. And for instance here, you see that in principle, what we see with the SIR model is the effective reproductive number is proportional to R0 times the number of susceptibles and the proportion of susceptibles. But in principle, this could only decrease. Okay? Then you see in the real world, the thing actually begins decreasing and so on, and then goes on jumping around the value 1. Okay? So how can it increase? Well, real world has lots of things like loss of immunity, new variants, and so on, which are not at the beginning, very beginning, nobody actually thought that waning immunity would be important, and that new variants would appear. I mean, people that work with coronaviruses, they know that variants exist and so on, but they expected that the turnover time would be much longer. And they didn't expect it to have new variants, more infectious variants, so after nearly a year. Right? So this was unexpected. So that's the thing the observatory did, it works. And then there's another very important point, and I think this is if you consider going to working with epidemic modeling and so on. So I told you that at the very beginning we just calculated the first calculations are 0, it was a different sign. And so we launched this in the middle of March. So 1 week later, an epidemiologist that I was not an acquaintance, not somebody that I knew, and the person didn't know me, just writes an email saying that I participated in a task force from the city of São Paulo, with the health department of the city of São Paulo, and we have this task force and to advise policy decisions. Are you interested in working with us? Yeah, sure. Yeah, very interested. So, and okay, next day we had a Zoom meeting. Zoom was Zoom meeting all the time. So it took 1.5 years to meet these people actually, and it was an open air. It actually was at a political demonstration. It's the first time I actually met these people. But okay, so there was this working group, and there were no modelers, right? No modelers, right? People from public health, epidemiologists, or just medical doctors. It was not very. So there were people from that worked at the department, the health department of the city, the secretariat of health, and then there were these epidemiologists a professor at a medical school here in São Paulo, a private medical school called Santa Casa, and people working with other things like there's the infectious disease hospital from São Paulo, Emílio Ribas, and so we actually learned so much with them, because all the story I'm telling you about the database and so on, so on. So I knew that this would be the database to be analyzed. Why? Because my connections to Fiocruz people that at the beginning of March we already discussed this thing. Okay, so but at that time the database was not publicly available usually. We had some trafficking with Fiocruz people that had the thing, but it was kind of not official, and then we had the data from the city of São Paulo because we are in the working group, right? So we started doing things for São Paulo, actually, and this has been very important to really manage this database, knowing what everything means, to talk with the epidemiologists, and also knowing what is important for policy decisions or not, what works, how do you communicate. So these people are specialists on this, and this was very important. We would not have done nothing like this without working together with public health people. And then what happened actually is that a month later, the Department of Health just said, we don't need you anymore. The whole task force, not only the modelers. Because the result, I mean, they don't want, it's when you don't know the things. Okay? When you don't have you have this working group. And obviously, we, from the universities, we put this publicly. We are public servants, and we put it on for free publicly. We are not doing consultancy. Okay? So the health department didn't like anything about this. Just a, yeah.
Or the national health department?
This was the city, São Paulo. At that time, we had only data from the city through this agreement. Yeah.
For how long you were together?
I can't remember exactly, but more or less a month. So it was important also. We actually, there were 3 people that are from the health department, from the epidemiological surveillance, and one of them is, they are not, I mean, they are not academic, they have, I don't know which kind of degree, but they do the day-by-day epidemiological work there. They are not PhD holders and so on. But one of them was very smart, and he loved a little bit, you know, coding and so on. So she had some idea of R and so on. So my colleague developed all of this, which is Paulo Inácio Prado from UNESP. Just, I mean, learned him to do it. And then when the thing was cut, he continued to do it. Okay, and he does it, but he was forbidden to communicate with us. Okay? But obviously, you know, WhatsApp is WhatsApp. So he communicates with Paulo usually. Okay, so just to check the results. Okay, so very, very curious thing, and so okay, so then. Why did they cut it? Because they didn't want if you say, when we are working with the city, we don't give advice to the secretary, the head of the Department of Health, and then we say, we think this and this, we should do, I don't know, masks or lockdowns and so on, and if the person, for political reasons, doesn't want to do what we propose, okay? It's better for him that we do not propose anything, okay? That we shut up, that you don't get the data. So therefore, he can take the decisions he wants, because these people are not data-driven, but they just think, okay, so they just think, what are they? Usually medical doctors, the secretary for public health. For health, yeah, for health. But then there has been something that I think was disastrous, is so many people were given interviews about what happens or not. Many of them were medical doctors. We had no experience with public health. They're just cardiologists, orthopedists, okay? One of the main persons was David Weep, who is a cardiologist. He knows nothing about public health. I mean, I don't say that you have to have a degree in public health or epidemiology, but I mean, you have to have some practice with this. Maybe you have a degree, I don't know, physicist or whatever, or you are a medical doctor, like this epidemiologist that first got in touch with us. She's a medical doctor, so she has a medical degree, but then she went for PhD in epidemiology and works since a long time with public health and epidemiology. So it's not that medical doctors don't know anything, but depends, okay? An orthopedist knows as much public health as anybody in the street. It's not his business, okay? And this has been very badly, I mean, managed by, for instance, by the press, by newspapers and press. Because sometimes we have a lot of contacts with the press, okay? So we have been in many times in the newspapers and so on. But sometimes people contact us and saying, can you indicate an infectologist who could maybe talk about R0? So it's not infectologists that talk about this. Has nothing to do. So that was, but I mean, it is very fundamental that you work in cooperation with epidemiologists, public health people, and so then, okay, so when they cut it, I was like, okay, no data. Oh, well, it happened that we have a contact with a person from the Mathematics Institute of the University of São Paulo, which had contacts at the government of the state of São Paulo, and then he said, oh, can you do this? Can you do the modeling for the state? Okay, you give the data, so you have the data of São Paulo. Okay, so very good. Was very, I mean, we didn't get the data at a very regular basis. Okay, some days because we don't have access directly to the system. So this guy from mathematics department had to download it. Sometimes he didn't have time. So, but anyhow, so, and then there was a working group at the government of São Paulo where we took part. I did not participate personally in this meetings. It's more the people that my main collaborators, which is the Paulo Inácio Prado and Renato Coutinho, who were on this kind of group. And this went on for some time, but it's very different from what you could ever think, okay? How to, so, okay, you'd expect that the health department of the government of São Paulo would be in charge of this kind of thing, but it was not. This group was coordinated by the Secretary for Infrastructure and Planning and Infrastructure and so on. Okay, so and you don't talk to her. Right? This person, you don't talk to her. We don't talk to her. So this person from the Institute of Mathematics had contact with her directly, but we didn't, and the working group didn't. And then there comes the curious thing. There are companies that do this work of, it's international companies. It's like McKinsey, Deloitte, Oliver Wyman, how it's called, the one that is involved with wars is, No, it's something taken from Tolkien. It's the the name comes from the book of the rings of so on. I will remember it. Okay, so but it's a big thing, and so what they offer for free to the government, that they will translate science to policies and talk to the government officials, the Secretary of Health, of whatever, and they will talk to us. So they do this. But yes, they have no idea of epidemiology. No idea. They have usually degrees in administration, economy, this kind of thing. Okay? So, but they are crisis managers. Right? That's what they do. So for free, for the government, they build these dashboards. Okay, they are dashboard builders. But then, yes, for instance, one of the first was with Deloitte. And so they wanted to know how to calculate R0 and make some projections and so on. Okay, good, very good. So the person then asked, can you project when it will be over? I mean, look at the credibility intervals and so on. There's no thing. I mean, if you say it will be over between 6 months and 10 years, it's the same thing as nothing. Okay? Oh, yeah. And then suddenly you're at a meeting, and there's a person showing the results. When it will be over, the peak, and so on. And you have some engineers from the from one institute here in São Paulo, called the IPT, Institute for Technological Research. And it was obviously wrong. I mean, they just fitted things like in logarithmic scales, and then they made conclusions completely wrong. Okay? And then I told the contact, I mean, it's wrong. Oh, professor, they are also scientists. Okay? And that happened all the time. Palantir is the other company. Yeah? Palantir. These are people are involved with very, very complicated thinking in the United States. Okay? So Palantir was also offering services to the government of São Paulo because they changed it from month to month. There were different companies, and it was always by dashboard and getting input from different modeling and kind of statistically because they have no idea of what is wrong or what is right, how to calculate things, and they don't know any math. So, okay, so that's. And they do it for free. Right? It's obviously not for free. This is making contacts. Yeah? Obviously, having contacts, having the information, they will sell this information to their clients. The customers are other companies. They want to know the epidemic situation. This has economic impact. They want to know it. So they know it, and they sell this knowledge. So it's for free for the government, but it's actually they made money with it, okay? So actually for them, it's more like we get the data for free, okay? And then, well, we do something, we do the dashboard, okay? And we sell also this to companies, and we have very good contacts for the future with the people from the administration. We can influence them. We have been friends. We will friends and commercially speaking, have contact. So that was something that I had no idea that this is like this. The Department of Health of the government of São Paulo and the city of São Paulo have people that are able to work directly with us, with the modelers. They have people. They have, at the beginning, at the São Paulo municipality, we had very good interaction. People understood what we did and so on. So they didn't need these intermediaries. Okay? And it's really, you see how things happen. And this is not only in Brazil, obviously. It happens, for instance, a lot in India. And this is also a consequence of not having very it is a consequence of policymakers and politicians not relying on their own institutions. And we have the field crews from Rio and from Bahia, for instance. They are very good epidemiological group, and they do modeling, and so they are already paid for. They are state employees. Okay, it could be done by them most of the things. Yeah, for policy advice. And then you have people at the universities. You have the Instituto Butantan here in São Paulo, who does not do epidemiology, but could convene a group from the universities, from the state. So they didn't need actually these intermediaries. But they do not trust the state. The policy makers, which are politicians usually, or sometimes more technical, they prefer to rely on this kind of private companies which have a lot of show off. The dashboards is usually something like this here, but very beautiful. Yeah, but very beautiful and very affirmative. It will happen this and this and this. So our advice is this and this and this. There are no error bars on this dashboard. No error bars. Everything's very precise. Okay? And then, and then there are also other groups at the universities, at the state universities, which don't know the amount of things they don't know. Therefore, they go on for doing modeling, which is not state of art. So our group, did not work with respiratory infections before. We didn't know how the database was and so on. But, we talked to people that know, And we are smart enough to see what is actually the state of art for this kind of thing. Go for the less preference and see what is the thing that important group use. And so let's try to learn it. And that's what we did. There are other people that don't. They have some idea, and then they do some modeling, and then they also have dashboards, for instance. Okay? Beautiful dashboard, no error bars. And we calculate R0 for all the cities of São Paulo, of the state of São Paulo. There's a group saying this. It's called InfoTracker. Okay? Has been a lot on the news, okay? And it's wrong. R0 is calculated wrongly. They try to use some kind of model that people, obscure group from Australia had developed 20 years ago. Nobody used this. And only they use it. And then they say they calculate this for any city. I mean, you know, smaller cities, they have a lot of noise, okay? There's no sense of calculating. For a city of 20,000 persons, R0 will not be informative, right? Or if you calculate it correctly, it will be between, I don't know, between 2 and 10. Like this, okay? Because you have to take into account the statistics, and so many people don't do this. Okay? And then it is also a battle of communication. So one other aspect of our observatory is that around April or May, or one person that actually the person is a biologist, and it's a teacher at public schools. I mean, teacher and for kids. But this person is politically very involved with a lot of things, and with science communication and other things. And so he joined at the observatory, and so she's like, okay, I can do the communication. Right? So communication, so Twitter, Facebook, and so on. And she's very good on Twitter. And Facebook is not so important, but Twitter is important in this case. And actually, this has been important. Not only, it's nice to have thousands of followers, but you actually are given to a larger population. I mean, it's still people that are on Twitter and so on. But anyhow, you are given reliable information. So it's not only the modeling in this case. Okay, it's a lot of things. It's the masks. We had a very strong campaign for vaccines, and we joined it with other groups also. Then there was a thing that called Everybody for the Vaccines, Todos para as Vacinas, which was, we participated with 2 other groups, which I mean have put like things like when there was no carnival in 2021, we painted all the street with vaccines. Okay? So I mean, people that have really good contact. Okay? That's having a person that is good with communication. Okay? So this is a very important aspect. We have also written a lot of what we call technical reports, but it's not technical in the sense of mathematical. But it's like, for instance, the last one was in January. It was about the self-testing, the tests that you can take at home, which were not available at all. Okay? So we published this on, well, we put it on a site, but also we sent it to our people that we know in the press, and it was on the main newspapers. And then, well, the ministry has to answer something, because the journalist goes there and says, okay, these people are saying that testing would be important and so on, but obviously then there's some pressure. And actually what happened is that months later, you got the tests, okay? It's always like this. It's always like, we pushed for free tests for all through the public health system, the SUS, and give tests also to contacts. The tests are not so expensive. And obviously what happened is, okay, the ministry allowed the tests in Brazil, but to be sold on the pharmacies. Okay? And well, there is some tests on the public system, but only if you have symptoms, and symptoms they are not tested always. It depends on the city, the state, and so on. So that was, yeah. So, but actually, we also had a lot of activity when the vaccines were at the beginning of 2021, when vaccines were not available, although they already existed. Brazil didn't buy the vaccines. And so we had also done a lot of public health science communication with newspapers, with TVs, and so on. And this has a big impact. So that's the non-scientific, strictly scientific part of the observatory. It's more the public face of the observatory, but this turned out to be very important also. Okay, you don't want to make pose any question? I can answer you, because the question was speak as much as you can, but I think maybe we can, if you want to know something else.
Maybe you can also talk about monkeypox.
Okay, monkeypox. So, yeah, same part of the same. I mean, we have a group of 4 or 5 people that are discussing monkeypox, which is actually my colleague Paulo Prado from UNESP, from the same epidemiologist that first contacted us, Maria Amelia Veras, and a student of mine, and a guy who was a statistician from Australia. I mean, Brazilian in Australia. So, the point is information. So, I can show you an email I just got. It's a site actually, which reports cases of infectious diseases which are maybe important in all the world. And there is a person here in Brazil, which is Rodrigo and Jeremy from the University of Campinas, who is the local coordinator. And sometimes there are things that are reported, and he makes comments. Okay, so just to have an idea of the situation about information, I will show you. It's in Portuguese, but I think most of you will get it. So it has been reported yesterday, the first pediatric cases of monkeypox. So just, I mean, if you are not following monkeypox is it's a virus, and if you take data, for instance, from Europe, 99.5% of the cases are in men. Okay? And overwhelming majority is men that have sex with men. Okay? And so why? Why? Okay? Because a woman or a person or a man that does not have sex with men can also get the thing. Okay? Can also, because there are cases, but the majority is the other ones. Why? So this is obviously still to be explained. I can give you an explanation, but I think it should be done. But okay, let me see if I can find this thing here. Okay, communication promoted. Okay, so Brazil confirmed today was yesterday, the first case of monkeypox. Varíola de macacos is monkeypox in Portuguese, but should not be used. People should not use varíola de macacos. It has nothing to do with the monkeys. There are people that will start to kill the monkeys in the wild, and it's because of this. It has nothing to do. It's actually not the reservoir. The reservoir are rodents. Okay? But now it's not even important, the reservoir, because we have the circulating in the human population consistently, not being imported from the rodents. Okay? The monkeypox is the same family of, but it's milder. It's milder. But variola, you get also this skin lesions, the skin problems, and fever. So it's, but I mean that there are people that die of smallpox variola, and there have been no deaths from monkeypox for the moment, and then directly connected to the disease. Okay, so it's milder, but it's still a problem because it can be very, very painful. Okay? Because this is a very complicated thing, but you see, is it sexually transmitted or not? That's a problem. That's a point to be made. Is it or not? So it's difficult sometimes to say what is sexually transmitted, in the sense that you can get influenza by doing sex because the person has flu, okay? But it doesn't make the flu a sexually transmitted disease. But what effectively, without going to the debate here, effectively it seems to be mainly through intimate contact. It's been spread through intimate contact. Well, obviously it is by touching people, so is it related directly to the sex or not? So we don't know, okay? Is it connected to unprotected self? Nobody knows, right? So for the time being, this is a question mark, but it is circulating essentially only, and it can be painful because, well, we think there are cases where people that have this skin lesion and things in the genitals, okay? And then you can have a lot of pain. Okay? So anyhow, so even if you don't die, it's still a public health burden. Okay? So yesterday there were the first pediatric cases in monkeypox in kids. 3 kids in the city of São Paulo, and okay, they are doing fine for the moment, and there's no information about how they contracted it. So then there comes the comment of the moderator that says, I cannot understand why many important informations are not made available, like how is the transmission occurred in general, not only for the pediatric case. No, there's no information about transmission, if they're imported or if they are from here, already circulated. How was it determined that this was monkeypox? Date of symptoms, onset of symptoms. That was the main thing that we had for COVID-19. That you don't have it for monkeypox. Okay? So because you don't have an open database, it's not available. Okay? There are people that are working on this. There will be some pressure because this epidemiologist that works with us, from the beginning of the observatory and is also working with monkeypox, Maria Amelia, she has a seat at the task force of the Ministry of Health about monkeypox. I mean, that's a lot of people, 30, 40, anyhow, but she's pushing a lot for data transparency and some modeling initiatives in Brazil. Okay? But for the time being, nothing. Okay? So, the epidemiological relation between pediatric case and the adult case. Okay? So, we have only the number of cases, and you have no idea of the rest. So, doing modeling in this situation is complicated, okay? Because, I mean, modeling for public health decisions, we can do a lot of models. Okay? But now, so I have some thoughts about what is important as connected to monkeypox. The first thing is if it is or not a sexually transmitted disease, it is can effectively be treated as one, right? And for COVID, right, or respiratory diseases, usually you don't know how you got infected and from whom. So it's can be even from nobody, in a sense that it's just in the air, it came from somebody that you even don't know. So, but as everybody has more or less, I mean, the propensity, the susceptibility to get infected and get sick varies from people to people, but more or less everybody is susceptible, could get it and so on. And so this kind of model, compartmental model that we discussed this week, worked well for COVID. But now, for sexually transmitted diseases, this is very different. But first you have to know the population at risk. Who can get it? Okay? In principle, everybody here. Okay? But if it's transmitted if it's connected somehow to sex, and it's the sexually active population. Okay? But you know there are spillovers like the kids, okay? Or people that have not connected necessarily to sex. Okay? There are other ways. But in this case, what you expect is that the network structure of the sexual contacts can be important for this epidemic. Okay? So there's a recent work by a group from the London School of Hygiene and Tropical Medicine, usually call it just London School, which was very active with COVID and so on. They said they had a work which is remarkable. I mean, it's just a preprint that appeared last week. Okay? But so it is puzzling. Why is the biggest part of cases are in men that have sex with men? Why? Okay, could be that you can raise many hypotheses. Like, I mean, maybe unprotected anal sex intercourse. Okay, could be. That's what people at first also thought about. Okay, maybe it's like HIV/AIDS, maybe. Okay? But there can be another explanation, which is interesting, which is the following. So, you know, public health in UK, it's very well developed and very they are very strong in public health research. So they have data not about the network of sexual relations. This is like almost impossible to have. You could say, can we get the network here of not only of the transmissions, but the relations? Okay? How would you map this? Even with people that, I mean, you can map, you have to do some survey in the population and use statistical methods. And this is not done from like that. So there are people, that's epidemiologists we work with, is proposing to do surveys about sexual behavior connected to, in order to explain monkeypox in the city of São Paulo, because you have to have some geographically defined region. But in the UK, they have not the network, but they have statistics of the network. So if you have a network, usually you make things like this. These are the persons. And each of the edges here is a sexual is the connection between sexual partners. Okay? So this has to be defined over some course of time. Okay? So, but what the English had, okay, so just you have this, then the number of edges of each of the nodes is called the degree. Okay? And the degree is just how many different sexual partners the person had over a course of time. In each case, it's 1 year. Okay? So you see there are people that have very few. This guy has only one. Then there are people that have a lot. So you have a distribution. Okay? You make a histogram, number of partners, and then you put the proportions of the population that had one, okay, to a kind of histogram. So we'll have something that goes like this. Okay? So that's a distribution, degree distribution. So they have, and it can be, the degree distribution is the number of sexual partners over a certain period of time. So they have this for, not related to monkeypox, just sexual behavior. And they have this for populations divided by heterosexual, men that have sex with men, and women that have sex with women. And they are different. So men that have sex with men have a different distribution and it has a kind of heavy tail. So there are more, statistically, there are more people at the population of sex that have sex with men that have a large number, big number of partners, like 40 per year or something like that. Okay, while the most of the case of heterosexual and women that have sex with women doesn't have a heavy tail. I mean, there are obviously people that have 50, for instance, sex workers. Okay, but statistically, this is not so important as it is in this other community of men that have sex with men. Now, epidemic on networks. The R0, for instance, does depend on not only the average number of sexual partners, but also the variance of the distribution. So there's a result that if the decay here has a heavy tail, if the decay is polynomial, then the variance is infinite. So R0 would be infinite, means that even a very small effectiveness would invade. Okay? But obviously this is very theoretical, because there's no such thing as a real heavy tail in the mathematical sense, because there's a certain number where it stops. So it's a truncated heavy tail, okay? Which will give you a variance that is finite. But anyhow, R0 is bigger if you have this truncated heavy tail. And what they set up, try to calculate R0, only for the degree distribution. Again, you don't have the actual thing, okay? So this is stochastic dynamics. Maybe we will learn stochastic dynamics next week, okay? So you do this, and they obtain it that R0 is bigger than 1 for men that have sex with men, and not. It's smaller than 1 for the other networks. Okay, so that's very elegant explanation. Okay, but maybe is it true or not? That's different. But at least it seems to explain that you have this situation with momkeepers being mainly with men that have sex with men, but does not. But can be transmitted to people that are not in the network. If there are people that maybe they have contacts with the men and have sex with men, but may have a woman or something that can go on. Okay, but for the time being, there have not been observed cases, at least what we know usually from data from Europe or Brazil, doesn't put many things, it just counts the cases. Okay, so it's very, very fragmented, very poor information. But in Europe, you have more contact tracing, and which is important in this case, obviously. And in this case, you have a lot of sustained transmission in the network of men that have sex with men. Then they have some spillover to other networks, but they don't form chains of infection. It's not transmitted anymore. So, for instance, a woman can get monkeypox, and usually she will not create a new case, okay? Or one case. It's statistical, okay? Could be a sex worker and have a lot of relations. Maybe she would create a case, but maybe the other person. The whole chain doesn't. It's just some sporadic cases. But that's what we have observed until now. So any kind of modeling has to do. I think it's my opinion that the modeling has to take into account network structure. Okay? But in order to, you can do something very, you can do something very theoretical here. Okay? But this has already been done, like last 20, 15 years. Epidemic dynamic of networks have been studied by a lot of physicists, actually, okay, with no real application. Okay, there are some applications, like global spread through airlines and so on. This has been studied with the view of application, but there are a lot of results which are more mathematical about how, just for fun. It's just it's an interesting topic and can be studied, and then can obtain analytical results, you can do simulations, whatever. Okay? So this has already been done, so there's no point of actually doing it. Okay? If I say if you want to do something with connection to monkeypox, you have to have something that's really connected to monkeypox. It's either the number of cases or the network or the degree distribution. So what I'm now trying to get is a degree distribution for men that have sex with men in Brazil. Okay? So this depends on contacts. So I told you that there's also a statistician working with us he's a Brazilian, has recently been hired in Australia, but he works with data from Brazil, and he thinks maybe he could get it. There have been some surveys, and not many, but they don't. He doesn't know of any survey in the population of heterosexuals here in Brazil, but of men that have sex with men, or trans people, or also sex workers. There are some surveys. So at this point, we are waiting to see if we can get something about Brazilian data in this case. Okay? But then there are interesting questions, for instance. One interesting question is, it is much easier to start an epidemic if you have the super spreaders. Okay? But now, once a super spreader is infected, this guy was infected. Right? Maybe he transmitted to this guy, but did not transmit to this one. So these ones are okay, they won't get it anymore. Right? So, nice. Okay? So, what you have, it's the dynamics on certain types of networks maybe this is dependent not only on the degree distribution, okay? For instance, if you have cycles, closed cycles, then you have something bad. If you have the cycles in your network and you start with the cycles, then sometimes you stay on in the cycle, okay? But we don't know. The network we don't know anyhow. But having dynamics with super spreaders, then you get easily invaded. R0 is increased with the number of super spreaders. But also you get a lot of people protected because it's not spreading with efficiency 1. So it could be, but this is very speculative, that the outbreak could be shorter, because if you get all the super spreaders infected, and then you stay only with the non-super spreaders, and then R0 is smaller than 1. But this is hypothetical, because we don't know even the size of the networks, which is important, and the number of super spreaders. And this is actually more complicated than this. So London School people, that they used this distribution for 1 year, and then considered that over the last 3 weeks, which is the time which is important for monkeypox transmission, that it was just proportional, 21 over 365, okay, somehow proportional. So, but well, obviously this is not like that, because this is actually a network that changes in time. Now, people, I'm giving you just a print of over a certain period, but there's a lot of variability, okay? And this doesn't mean that these partners are even known to the person. It can be orgies, okay? And then you don't know. And then you have lots of contents, but concentrated on some days. And that happened in Spain, clearly. Okay? So, lots of unknowns. But speculative could be if the super spreaders are over. So people think that the immunity is taking it from smallpox. People think that monkeypox should give you immunity to lifelong. I don't know lifelong, but anyhow, but cases that have been studied in Africa, people are getting there are no people that had been reinfected. But also, the prevalence is very low in Nigeria, where from comes this variant. There's another variant in Congo, which infects much more, and it's more severe. Yeah? But this has not been circulating in Western countries. It's in Congo Brazzaville, and yeah. So that's it. If you go to the archives, like medRxiv, where all the things from COVID appear and so on, the preprints, and look for monkeypox, the whole archive has 35 preprints, of which like 10 or 12 are connected to this outbreak. The other one are historical. So no model. The only more quantitative preprint is the people from London School with this degree distribution thing. So we're still in the dark for this. But obviously I'm interested, and we are trying to convene a group, but we are without many information. We should have more information, like the guy the moderator does. They just count the cases and say which city and the case. And then they don't have the date of symptoms, for instance. How long did it take to confirm? Sometimes it takes a long time. Then you have still to go to the press. Okay? If you look at the data from Brazil, there's a nice site which is called health. It's called global. .health, and they have a nice dashboard and so on. It's people also from I think from London School and from Oxford and so on, with data from all the world. Right? You can get the plots and so on. It's nice. If you look for Brazil, so you can get an accumulated number of cases, but you can also get the daily. But then you see things like 0, 0, 0, 60, then 10, then 2, then 100. Wait, this is not connected to the dynamics of the epidemic. That's the confirmation. It takes time, and sometimes they don't communicate because there's no database. The communications is just the daily report by the Ministry of Health. That's what you have. So people pushing to modify, to change this, but no. Ministry of Health is always slow, and it's particularly slow in this case. And so the dynamics could be affected. The dynamics, you should not do the same thing as in COVID. We have the daily number of cases and we fit it to months. This will be probably not possible. What you can do is take the accumulated number of cases, which is more regular, because it's accumulated, and maybe use this curve to so my first idea was, okay, I will take this curve and it's an exponential growth for Brazil or for Brazil, or we could do it by state also, and let's calculate the intrinsic growth rate, okay, the R, and connect it to R0. Okay? But this procedure here, I think is not valid for heterogeneous networks. I'm not a specialist on networks. But I talked to a guy who is a specialist in networks, also from Australia, has written a book on it and so on, and he says he's in doubt. He has not really thought a lot about it, but maybe he thinks that maybe you can use it, but your R0 will not be connected in the same way to the total size of the epidemic like we had before, because it will be different. Okay? But also if you have the cycles and so on, then he says he would be careful to do this kind of thing. So there obviously are already people doing it. Okay? Yeah, there are always people that do it for the data of all counters in the world. Because why? Okay, it's not difficult to fit an R. Okay? And if then you say, okay, I know the serial time or the generational time, it's a matter of calculation of one page. Okay? So you write a code and you plug data from all the counters you have on this website, and you calculate an R0 for every place. So what's the importance of this? I don't know. Will it be useful? Or we don't know. It's different when you have this kind of complex networks than if you have the usual compartmental models where you can do this. Some more questions? Yeah. Yeah, okay, there, and there. So you start, then you, okay?
Sorry, I didn't get the chance to write my question, but going back to COVID, could you comment a little on the global models? I think like the groups which modeled different countries, and I think there was a lot of going back and forth, at least during some time, relating to those models.
Yep.
Things going to the Lancet, being removed. Can you?
Yeah. Okay. So let's see. How are the models that are usually, seen seriously as models for COVID? Okay. So I will show you one. Okay. That's our model. No, it's a model from, we work together with people that are based in Oxford, and they have kind of something called the Consortium of Modelers, called COMO. And this is a collaboration with, mainly with, there's Oxford and there's Cornell. And then the other is, participants are people from low and middle income countries. And so there's some more developed, this Brazil, South Africa, Thailand, and so on, but I've grouped. But this group also, this consortium also makes available code to be run by people that maybe know how to run a code, but don't write themselves as models. So from low-income countries. Okay, so that's one particular model. It's a compartmental model. As I think it's open somewhere. Okay, that's the kind of model that, for instance, we use. We have used. We don't use this for. Oops. What happened? It's okay? So, we don't use this to calculate R0, or the R0 is called, we use the nowcasting and the model-free calculation, okay, and the RT also. So this is a model that you have the susceptibles, then they have incubating people, then they can get to infected with no symptoms, and they get infected with mild symptoms, with hospitalized, and then you get uninfected immune. And at the time we were writing this in 2020, there was this set of return here because we didn't know if immunity would be how long. Okay, and then you get uninfected, you get hospitalized, then you get the ones that are ICU treated and hospital treated, but then there are the ones that need to be hospitalized but didn't get it. And then the people that have to go into ICUs but didn't get it. So they have different death rates here, and this is mortality. All of this is divided in 20 age classes. Okay. So this is one model. Okay? So that's the kind of thing that you can do. This one is a deterministic model. Okay? But you can do, as you have the data all with distributions and so on, you can do the calculations also with credibility intervals and so on. So this is like one of the things. Then there are other models, stochastic models, and people from the empirical culture use stochastic models, for instance. But it is something which has something like this. So this, okay, maybe they don't have so much things, but this is done. That's the Brazilian version. Okay, but it depends a little bit on what's the particular situation of a certain either city, state, or country, and what of those connections you know. Okay, so the other countries maybe will have some variation of this. Okay, so this is the kind of model that may be used for scenario exploration. We don't have something like predicting things. Forget about predicting. Okay? But you can explore scenarios. Say, okay, here we don't have vaccines, for instance, but we can put vaccines. Then you can study the best delivery way of vaccines for which age groups and so on. And then you can make scenarios of reopening schools. You can make scenarios of the influence of a household against general population and transmission and household transmission. You can incorporate this. We have a book on that. And so this is all scenario exploration. Okay, predictions for 1 or 2 weeks. Okay, maybe a month. Okay? But otherwise, it's difficult. And also, all the models make a lot of assumptions, and the assumptions sometimes can not be true. Maybe they are not true. For instance, variants. Maybe nobody had an idea that a variant would emerge, and we don't have even a good idea of if there will be another variants, and that has a whole connection with the evolutionary theory for virus and so on.
So, for sure, I am thinking one simple question, because we already get out of a pandemic and we have now one outbreak of one disease. Do you think this is common, or we have an increase of pandemic and an endemic in the world, and something is causing this?
No. So this is a question actually about emergent infections. Okay. So usually diseases emerge from contact with other animals, with other species. That's the common way. So, is the contact with other species increasing or not? Okay? That's the point. So, what could be related to what? It can be related to deforestation, for instance. You have more borders. Could be related, and that has been shown in a paper in Science from 2 or 3 days ago, that COVID came from a live animal market in Wuhan. Okay? So shown up to, what people consider shown in science. Okay, there's always some uncertainty, but that has been pretty much well established, and that's actually there are markets that sell live animals. And then, for instance, the previous epidemic of SARS in 2000 and something was connected also to infected animals. So people think that bats are the host producing, but there's not so much contact with bats, but bats maybe transmit to animals, and maybe this is an animal of commercial interest. Okay? So for instance, SARS was also connected to live animals, because you know, they take the fur, okay? So they take the fur of the animals alive. And that's where it's a very intimate contact with the and in the case of monkeypox, seems to be the rodents that have been hunted, and that made the spillover. So is this increasing? So there's a lot of debate on that, actually. Can climate change have a influence on this? Yes, it could, because climate change, in principle, can change the niches of certain animals, and they would have to move to places where they can survive. Okay? So then you have the question, will they be able to move or not? If they don't, maybe they get extinct, but maybe they move. If they move, they maybe bring new pathogens into a place where these pathogens didn't exist. So there has been a very recent work, I think it's a paper or preprint, I don't know, which is super huge work which connects climate models with in climate scenarios with species distributions, and tries to calculate the number of new species contacts which could spill over to humans, and they have tried to calculate where would be the hotspots. So hotspots are India, southern China, Indonesia, and all the Indochina, and these kind of places, and there would be a potential hotspot in the Amazon. But this group made two simulations with dispersal, restricted dispersal, or with considering can the species actually, they have to adapt to go in a place, can they go there? If they don't, then they, or either some part of the species will adapt to the new conditions, or they will get eliminated. And well, if you take this restricted dispersal into account, then the Amazon is not anymore a hotspot. Right? But so, is it increasing or not? This is difficult to say, because it's it's a rare events. Right? So, next question.
I have more of a curiosity about the monkeypox. You said that we don't have data about it. And is that common in usual outbreaks? And I'm thinking about that because we have the COVID and didn't have a lot of data. And intuitively speaking, it would be easier to get for monkeypox instead of COVID, right?
Yes and no. What kind of data? So, counting cases. Okay. So, but you would like a database with the day of the first onset of symptoms. You don't have this. And this is important for modeling. Okay? So, it is maybe easier to get there is a question of, are they asymptomatic or not? Okay? So, it is possible. It has, if it's asymptomatic and there's no much surveillance on that, then obviously maybe it exists, but we don't know. That's pretty much possible. Right? But well, there are people in Belgium that have done work with blood donors. They tested a bank of blood donors and found some positive cases for monkeypox DNA. And they contacted people, and these people had no knowledge of that, had never have any symptoms. Okay? So that's a preprint also from the last days. Okay, so there is the possibility of asymptomatic, but well, then there's also the idea that asymptomatic don't transmit. Okay? So many questions. So so data about monkeypox, the counting number of cases maybe is easier than with COVID, but having information of the onset of symptoms and the relation to sexual activity is very difficult. In particular, the relation to sexual activity. There is being discussed at the Ministry of Health here in Brazil, what's called the Nullification Form. Okay? The things that can be a doctor or a nurse or at a health facility asks in an interview with the person that had been diagnosed with monkeypox. And there's one question is like have you had sex over the last 3 weeks? Okay. Which is nothing. There are many people that have sex in 3 weeks. Okay, so the point is that so I suggested through this with talking with this epidemiologist, which actually is at the committee at the health center, that they ask the number of partners. Okay? Well, the best would be asking the number of partners and saying the partners, who are the partners, and contact trace the partners. Okay, but this is not viable. Not viable. Okay? But there could be at least a question about the sex of the partner. So we are talking about the men that have sex with men, but this is not a finally established thing. Okay? So there is this explanation, an elegant explanation of people from London, so on. Maybe it has to do with this, but we also want to know what other cases exist and what's the risk for the other populations also, and actually what's the real risk for men that have sex with men. For instance, a student of mine, he's finishing his PhD on dengue and so on this next month, but he already has a job at the, a short-term job working at the epidemiological surveillance of the state of São Paulo, doing data analysis with them. So he knows people and that are at the front lines. So with this notification thing, and these people say that most cases are people that had several partners. There are no many, but that's anecdotal. Okay? It's a guy at the coffee telling this to my student. Okay? Saying most cases are people that had at least 5 partners in the last 3 weeks. So this seems to be connected to network structure. If you have real data for that, you can estimate risks also. What sexual behavior is more risky than others? Or what's the risk of having this going to, maybe not for the general population, which is sexually active, but the subgroups? For instance, sex workers, is this, what will be the importance of sex workers? Huh? Or are they at high risk? You could imagine it, maybe. But for all of this, you would have to name data, which are not available, and it's not viable for the Ministry of Health to ask. So what we are trying, it's this epidemiologist, Maria Amélia Benes, is trying to at least ask the number of partners. Okay? And maybe that was also suggested when. Because it's over the last 3 weeks, but we would like to know the serial interval. Now, on the serial interval, you had, or for incubation periods and all of this, you had to know the day the people had sex, right? And then you could do some statistics and try to infer the time between infection and time with symptoms and so on. But what would be more and more interesting would be the contact tracing. This is not viable at the level of the ministry, okay? Because nobody will, I mean, people, so there's a problem with all this data. Okay, I will finish in a moment. So all of this data about sexual transmitted diseases is that people lie, okay? And yeah, if you take at face value, but in the newspapers, oh, number of sexual partners of average Brazilian. I mean, it seems that everybody is doing sex all the time. It's probably not true. Okay? So, because people answer maybe not the number of partners, but how many he would like to have instead of actually having. So, okay, this is a joke. Okay, but now you can do surveys, which is not the ministry. Okay, that's more academic. In order to do surveys, you use techniques where the population being surveyed is also taking part as people that do the interviews. So you need to have, it's called a Snowball Technique. Okay? You have people that, you have to have an initial fraction of people that work with a group of epidemiologists. And these people, for instance, this is done for studies in very poor transsexuals, usually transsexual women, and many of them, and the poor people. There are many sex workers, and they won't tell this to the doctor, but they tell it to people that are also sex workers, for instance. So you can get a survey, okay? That's, some kind of survey. And so, well, maybe this kind of technique could be important for monkeypox in order to get information about networks, frequency of actual relations, and so on. So, but this is still, for instance, this is a person that I know is actually writing the project. But the person is writing the project, still has to get money for it. It will take months. Okay, even if you get it more or less quickly, they have to put a whole team together to do this. It's not something that you do. Whoop, like let me make a small calculation here. Okay, so it's different. Anybody else would like to ask something? It's over, eh? Yeah, but anyway. Okay, you can ask me. Okay, we have a meeting at 2, okay? In a happy hour. In a happy hour, yeah. No. Okay.